Now, let's write down the definition of both physical and chemical properties. Go to the next clean page in your matter section. Write down physical properties, skip about 4 lines, and write chemical properties. A physical property is one that can be measured or observed without having to change the matter itself. For example, our scientist's notebook has the physical property that it has mass, and if we want to observe or measure its mass, all we have to do is just put it on a balance and see how many grams or kilograms it has in it of matter. So we don't have to actually change the scientist's notebook to measure its mass. Another physical property that it might have is that it might be a conductor. If we wanted to measure or observe whether or not it's a conductor, all we'd have to do is maybe put it into a circuit and see if the circuit still works with the scientist's notebook in place of one of the wires. If the bulb in our circuit still lit up, then we would be able to say that the scientist's notebook was a conductor, that it had conductivity. But testing that out or trying to observe it wouldn't actually change the scientist's notebook. It'd still be made out of the same thing. So those are examples of physical properties. However, the scientist's notebook also has properties that are chemical. For example, it's flammable, and the only way to observe its flammability, to see it in action, is to catch it on fire. Once we've done that, the scientist's notebook would be changed and changed chemically. Part of it would escape in gas form to the air, and the remainder would be changed into ashes. So, a chemical property is one that can only be observed or measured by changing the matter. Copy down the definition of chemical property now. Now, you can see that this coffee maker is definitely flammable. Afterwards, we would be unable to easily put it back the way it was. Flammability is a chemical property. However, just like all other physical properties, such as conductivity or magnetism, not every one applies to every type of matter. Not all matter has every chemical property either. Can you think of a type of matter that doesn't have flammability? Metals are a good example of something that's not typically flammable. Now, let's look at a few other chemical properties. Like flammability, you've likely heard of them, but didn't know that they were actually chemical properties. One is tarnish. Have you heard of it? We have a couple of examples. Let's look first at these pennies. You might have had one of the pennies the other day that had that greenish blue powdery stuff on it. That was a material called tarnish. What are pennies made of? At one time, pennies were made completely of copper, but now they're a mixture of copper and zinc. And copper has a chemical property that it will tarnish when exposed to water and oxygen. What that means is that some of the copper actually chemically combines with the water and oxygen to make this greenish blue material you see. If left alone, it'll completely cover the penny. Now, you can remove the tarnish, and the penny will look like new, but it has been permanently changed. If you could put it on a balance sensitive enough to pick up the difference, you would see that there is slightly less copper in the penny than before. Part of it combined to make the tarnish and was removed when we removed the tarnish. Another famous example is the Statue of Liberty. A gift from France to the U.S., it's also made out of copper, but you wouldn't know it by looking at it, would you? It's completely covered with tarnish. You might wonder why we don't remove the tarnish. We could spiff it up every so often, but it would be a mistake. Once that outer layer of tarnish forms, it actually protects the underlying copper from tarnishing. If we kept removing the tarnish, we would eventually keep losing more and more of the copper in the statue because some of it combined to make the tarnish. Silver is another material that tarnishes. Notice that silver tarnish looks completely different from copper tarnish. Silver tarnish is dark and feels gritty, and just like the copper tarnish, it can be removed. but some of the silver is lost with it since it formed from the surrounding oxygen and silver combining. Even though it would look the way it used to after you removed it, part of that silver is gone now. And so if you put it on a balance, some of the silver, the mass would be a little bit less than it was before because some of the silver combined to make the tarnish. Here's one you've seen lots of. Rust. Iron is a metal that has a chemical property that it will form rust or iron oxide by combining with the oxygen and the water in the air. The rust that was formed is actually weaker than the iron that it was made out of. So much so that sometimes a rusted piece of metal can easily be broken. Even if we remove the rust, we could get a steel wool pad and scrub this chain here and make the rust sand off. But part of the iron is gone forever. It combined with the iron and the water and formed the rust, and when you removed it, you removed some of the iron with it. And here's our last example, reactivity. Some materials have a chemical property that they will react when they come into contact with certain other materials. For example, sodium metal. Remember what it does when placed in water? It immediately begins reacting with the water and combines to form a gas and actually ignites and explodes. Do all metals do this in water? Of course not. This is a chemical property that sodium has with water. You may have seen someone do one of these volcano demonstrations using baking soda and vinegar to model the motion of lava coming out of a volcano. Baking soda and vinegar have a chemical property that they will react when they come into contact with each other. Let's look at a video of one of our lessons where we combine baking soda and vinegar to see their reactivity. Watch and listen carefully.